So I have prepared a script which could identify all the reference leaks in cluster. So the reference leaks are a bit tricky, or you can say a bit difficult to identify, because we are using here memory pool. So the memory allocation gets memory is allocated every time from memory pool, but there is no dedicated owner of that memory which could always point out to this memory. So to identify from the code paths which function is leaking is a bit tricky. So here I have used a very simple and easy to use tool, that is system tap. System tap is just like any other debugging tool, in which is used to trace the kernel as well as user space processes fairly easily. Some of the good things about system tap is that we can we can probe a running process and analyze what are the values of some target or specific variables which we want to analyze without disturbing the ongoing process. And it have its own language in which we can write a script to analyze a particular task. And it's one more good thing about this is that it does it doesn't in, it doesn't interrupt the ongoing processes. And yeah, we need not to reinstall suppose we need not to reinstall a kernel to check what are the values of some specific variables. So it's quite useful for this scenario also. Here I have written a small script which could identify the leaks and dump it in a file. So here is the script. Okay, first let's go through the source code of cluster. So this script is useful for only for when the leak is because of reference functions like dictref or inoderef or say fdrefs. So whenever a process requires a memory, it's calling a function say dictnew, which in turn calls this function. After taking memory, it is calling a function dictref, which we know that. So what dictref is doing, this dictref is in taking a ref count and increasing it every time when a function is dereferencing this memory. So we are every time increasing the count, and when this memory is utilized, a function is called that is dict unref, which decreases the ref count. So we are probing these referencing and unreferencing functions to track the value of this variable. If this variable is 0, that means there is no leak, but if the variable is non-zero, that means there could be a possible leak, and we could analyze that from the output. So here we are probing processes. Probing in system tap is similar to what we are doing by putting breakpoints in GDB. So we are probing cluster process, and using this library. And what argument user provide means whatever function he wants to probe, he can provide it on runtime when the script is run. So this function is taking tracing that ref count, this variable, and putting it in an array that is count. And this is an associative array whose index is the pointer, whose index is this pointer, and whose counter is counter is ref count. Here I have used casting to cast or to tell the script that this pointer of this data structure is casted and casted into ref count variable. Then there is another array trace underscore ref. which is keeping all the traces when the given function is probed. The same is working on with dict unref, or say any of the unreferencing functions. The same logic applies. Here we are decreasing the counter and tracing all the back traces. And if the count is 0, we are deleting the traces for the pointer whose count is 0, as well as unref traces and that count value. And this is another event timer which is triggered after a specific time interval. This is also provided by user, and it is calling a function aggregate. This function is printing the output. It's first checking whether the count is 0 or not, and if the count is non-zero, it is printing all the ref traces as well as unref traces. And after that we are dumping the output. We are deleting all the data structures, we are deleting the count values, ref traces as well as unref traces. So it's fairly simple and easy to use script. So to run this script, I have prepared another shell script from which this script can be easily run. So let's run it. It's asking for the function which you wants to probe. Currently I have provided 3 referencing functions, so let's probe say dict unref function. Then it's asking for the process ID. Let's check cluster processes. So let's probe which process. Okay, so let's probe this glusterfs process. That's a client process 4907. Okay. Then it's asking for the output file name. Let it be text1. Then it's asking for the time interval. So the script will probe and produces the output after few seconds or few minutes. So let's give it say 2 minutes, and so the script will produce the output at this location after 2 minutes. So what's going on? This is the command which is running in background. So this step is the front end command for running system tab. -d option is used to provide all the modules which the script needs to utilize for producing the traces. So the script will analyze analyze the process ID. It will analyze what is the function corresponding to this, what is the process corresponding to this process ID. Is it glusterfs or glusterfsd or glusterd or whatever. Then it will take the required shared object files needed for this process, and the rest it's we are increasing the string length. The strings are utilized in the arrays. Then it's taking the process ID, and the rest of the arguments are normal. Okay, so this system tab works in 5 passes. First we have to do the fops. Let's do some fop. Okay, so we are mounting this client process. Let's do fop at this process. Okay, mkdir file1 and rmdir file1. Okay, that's fine. So one thing we should make sure is that whatever time interval we are giving, we should make ensure that all the fops need to be done in this time interval only. And this system tab works in 5 passes, or we can say 5 rounds. In the first round, so let's understand this 5 passes from this script, from this diagram. So in the first part, this system tab script will parse the script and code and check for the semantic and syntax errors, and then in the second pass, and it debugs the data, and in the second part It analyzes what are the probe points and functions and replaces predefined functions from the library. The system type library is called debset, and then it translates translate the file into this .c file, and this .c file is converted into kernel object file using some of the tab sets and runtime libraries. This kernel object file is probed into the kernel in the fifth round. So, sorry, it's inserted into the kernel and starts running. When this kernel object file is running, it is putting probes at the required points, and whenever these probe points are triggered, it's fetching the information from them. So let's go to this path to check. Cool. So for the first round, that is for the first 2 minutes, it has printed net ref count for each pointer. It's printing ref counts for all the pointers which are affected, and if it is non-zero, it's showing what are the traces corresponding to them. For this pointer, the count is 1. That means there could be a leak. So it's showing first all the ref traces. These are all the ref traces and the unref traces. So from this, we can easily analyze by going to these code paths and checking which function has called dictref and which function is called dictunref and where is the leak. So whenever we have any whenever we find any issue, we can easily use this script. Thank you.